Okay, hey guys, so we're going to be doing Cramer's rule again, but instead of it just being an x and a y, we're going to have a system of three equations here. All right, so I've got x plus y plus z is equal to 4, and then I've got 9x minus 3y plus z equals 32, and then I've got that third equation as well, and we're trying to solve for x, y, and z so that it balances all three equations. All right. Now, in the past, we have done these. All right, we did them in this format right here with our calculator, and this was called an augmented matrix. To use Cramer's rule, though, I mean, it's really similar. We're going to set up, well, you don't even have to set this up right here. All right, this is just kind of how it works as far as the notation goes. But to do Cramer's rule to solve for x, y, and z, what we're going to do first is we're going to find the original determinant, all right? And then we're going to do the determinant in x, and I'll show you what that means again. And to solve for x, what we did was we did dx divided by d, where these are both numbers, and that would come out to be the answer for x, all right? So let's go ahead and get started here. I'm going to do the first two determinants in this video, and then the y and z down below, we're going to do those in a separate video, all right, with a calculator actually. So the determinant of the original matrix here, all right, this original matrix. All right, so because it's a 3 by 3, there's going to be a completely different process, unfortunately. I'm going to show you how this works. It's called expansion by minors. That's what it's called. So remember these little bars here, that just means the determinant of. And what I'm going to do is I'm going to pick a row or column, and I'll kind of work through it with you. But typically you would use a row that has, if there's any zeros, you would use that, or if it had a bunch of ones. So typically I would use this first row or this third column. But to avoid some confusion here, I'm actually going to do one of the other rows or columns. I'm actually going to go with row, I'm going to use row 3 here. Okay, so it starts off, you can circle this number here. And what we're going to do is I'm going to draw a line vertically that kind of cuts those numbers out of the way, and one horizontally that cuts these out of the way. So my first part here is going to be 4 times the determinant, so the 4 comes from the one that I circled, right, times the determinant of these leftover 4 pieces right here. So 1, 1, negative 3, and 1. All right, that was the first part. Okay. So I circled the 4, and then I kind of crossed out horizontally and vertically. Now I'm doing row 3, so after I do the 4, now I'm going to move on to the 2. All right, and the way it goes is you don't adjust the sign of this first piece at all. You just leave it positive. But the second term, you're going to have another one here. It's going to be a minus. So it always goes plus, minus, and then plus. I'll show you what I mean by that. Okay, so I'm doing my 2. So it's going to be 2 times the determinant of, I'm going to mark these pieces out. I'm going to mark it out horizontally. So it knocks out the 2 and the 4, and vertically. All right, so these leftover pieces are my 1, 1, 1, and 9. And I'm going to do the determinant of that. So 1, 1, 9, 1. Okay. And then it's going to be a plus. Let me come back here and clean this up a little. So I've already done the 4 and the 2. And next up is going to be this 1 right here. So I'm going to cut vertically, knock those out, and cut horizontally, knock those out. And so this is going to be a 1 times the determinant. See, that's why I didn't use these 1s up here. It is easier if you use them, but I just didn't want the notation to get all too cluttered and confusing. The leftover pieces are 1, 1, 9, and negative 3. All right, so I'm going to work this out, and this is going to be my determinant of the original matrix. Okay. All right. To find the determinant of a 2 by 2 matrix, you multiply these, so 1 times 1, and then minus 1 times -3. Well, 1 times 1 is 1, and then you're subtracting a negative, so it becomes 1 plus 3. So we're doing that 4 times this 4. All right, and then minus 2. 1 times 1 is 1, and then minus 9. 1 minus 9, that's -8. All right, plus, and there's a 1 here, so I don't even have to write it. Let's see here. 1 times -3 is -3, and then minus 9. So that gives us plus -12. Work this out here. We're going to get 16 plus 16, because you got the double negatives, and then minus 12. So 32 minus 12 is equal to 20. All right, that was our original determinant, was equal to 20. All right, erase this. Bam, 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 bam. All right, original determinant is equal to 20. Scroll on down here. All right, next up, we're going to be doing the determinant in X. Let me at least show you the setup for how to do this. So the determinant in X, this was my Y and Z column from earlier. Those don't change. All right, those are, I'm going to keep the exact same. But for my X column right here, I'm going to replace that with my answer column, 4, 32, and 7. Okay. So I got to set that up. 4, 32, and 7. Okay. Yeah, 7 minutes. Okay, we're good. We're good. All right. So I could use the bottom row like I did last time, or I could use the top row. I could even use this third column if we wanted to. I think I'm just going to use this top row. All right, I'm gonna do the expansion by minors of the top row. So you start with the top row, so number 4, and it's 4 times the determinant. All right, and then we're going to mark out horizontally and vertically. Okay, and then the leftover pieces, -3, 1, 2, and 1. Now remember, this one was plus, this one was regular, and then we do a minus, and then, oh gosh, yeah, got to clean this thing up. Okay. All right, so I'm doing row 1, so I've already done the 4. Next, it's going to be this 1. Mark those out. Mark these out. And because it's a 1, I really don't even have to put anything. All right, I just got to remember I'm subtracting. I'm subtracting this determinant. All right, and the numbers are going to be 32, 1, 7, and a 1. And then the last one is going to be a plus the determinant. Let me mark these out. You can probably already tell what it is. Okay, the determinant. And I'm using this 1. Come on, there it goes. Marks these out, marks these out. And I've got 32, -3, 7, and 2. All right, now I got to work this out, and that's going to be my determinant. All right, so it's 4 times the determinant of a 2 by 2. We're going to have -3 minus +2. It's -5. Okay. Catch up with me. Catch up with me. Okay. And then minus the determinant. This is going to be 32 minus 7. So that's 25. And then the last one's going to be plus This is going to be 32 times 2 is 64. And it's going to be a plus because we've got, 7 times negative 3. And that's 21. So what's that come out to? 85. All right. 4 times negative 5, that's negative 20. Negative 25 plus 85 is about 60. And then negative 20 plus 60 is 40. That's my determinant here. Equals 40. So I'm going to go back up here and save this information. All right, now in the next video, I'm going to show you how to do this with a calculator, and it's a lot easier. Boy, it's a lot easier. 2 by 2 determinants aren't too bad, but 3 by 3s, those take a while. All right, and if it was a 4 by 4, I'm just going to mention this. If it was a 4 by 4, it really does the same process, but it takes forever. All right, when you cross out, the vertical and the horizontal, you're left with a 3 by 3 matrix. Never mind. It takes forever. I'll tell you that.